Mechanics of a system of particles. Mechanics of a system of particles. In previous lecture, we learned the mechanics of particles or say single particle. Mechanics of particle or a single particle. Today we learn mechanics of a many particle system. Mechanics of a today we learn mechanics of a many particle system. Mechanics of a many particle system. On previous, we know that the equation of motion for a single particle is a vector equal dp dt equal p vector dot. For a system of particle, for the system of particles, there is two type of force. There is two types of force acting on the systems. One is external force, AP, external force, and other is internal force, F, internal force. Equation of motion for a particle, for a system of particles. Equation of motion for a system of particles. System of particles is summation J F G I vector plus summation F I E equal summation P vector dot or PI vector dot. We get the equation of motion summation if gi plus fi equal pi vector dot. There is fgi and fi. Fgi is the internal force on the ith particle of the many particle system due to jth particle. Fi is the external force and pi vector is the linear momentum of the system. Linear momentum of the system. Say this is equation 1, and if we sum over this equation 1 to many particle system of all other particles, then we get this equation becomes summation I comma j, I not equal to j, if ji plus summation fi equals summation pi vector dot. Here if gi vector does not happen when I equal I, because internal force on ith particle due to ith particle is not possible. Now again we write the equation summation I comma j, I not equal to j, if ji plus summation I fi equal summation pi vector dot, or summation, here we write pi vector dot equal d2 dt to summation mi ri vector equal, and this is summation I comma j, I not equal to j, if ji vector plus summation I fi. Now we introduce a term r vector such that which is equal to summation mi ri vector divided by summation mi equal to summation mi ri vector equal r vector summation mi. Summation mi is the total mass of the system. which we can say M equal M R vector, or summation we get summation M I R I vector equal M R vector. Now summation M I R I vector equal M R vector. We write this value in the equation 1. We get d2 dt2 summation d2 dt2 M R vector plus summation I F I E vector. Sorry, d2 dt2 M R vector equal summation F I E vector plus summation I comma j I not equal to j F j I vector. Here F j I vector is cancelled because F j I from Newton's third law of motion, F j I equal minus F I j, because action and reaction is equal and opposite. If ith particle apply force on jth particle of value F, then jth particle also apply force on ith particle of equal value, and direction is opposite. So F I j minus F j I cancel each other equal 0. So this term equal 0. So finally we get the equation of motion for a system of particle is d2 dt2 M R vector equal summation I F I E vector. From here we get the conservation theorem of linear momentum of a system of many particle system. Linear momentum for a system of particles, not a single particles. System of particles. It is not a single particle. It is a system of particles or a many particle system. Then what is the conservation law? The conservation law is if external force, total external force F I E vector equal 0, then d2 dt2 of M R vector equal 0 equal M d2 R vector by dt2 equal M, or d2 pi vector by dt2 equal 0, or integration d pi vector equal 0, or pi vector summation pi vector equal constant. This is the conservation law of linear momentum for a system of particles. we say that if external force Fi vector equal 0, then P vector dot equal constant.